Right, so hi everyone, I'm Elliot. My talk is also on performance in React because we're hitting a bit of a theme today. Hopefully this is going to be a bit complementary to the last one as opposed to conflicting. But it's mainly going to be focused tips and tricks, kind of some low-level kind of implementation stuff. I'm Elliot, as I said, I'm a full-stack engineer, mainly front-end, working at Hyperexponential, or HX for the lexically challenged. We are sort of a small fintech startup working out of Peckham. We build frameworks for modeling and data science using sort of small, fun, quirky data sets that everybody uses, nobody really talks about. So generally, yeah, as I say, we're going into some really low-level stuff today, things that you can actually use in your code and some best practices that might have just been covered very briefly before. So who am I? For about the third time, I'm Elliot. I'm 22. I'm an Imperial student still for one more month. My dissertation's actually on the 17th, so I don't have very long, which is why I kind of have to apologize for doing this in PowerPoint at a front-end meetup. That feels like a cardinal sin, but I didn't really have the time to pick a Gatsby starter project with 4 stars and 40 open issues. So I'm a full-time, full-stack, but mainly front-end engineer. I've been at HX employee number 1 for about a year and a half. I'm a React enthusiast first and foremost, so at the moment I'm just turning all my components into hooks-based components, even though that everybody says not to, but fuck it, I live on the wild side. And I'm also a competitive rifle, pistol, and shotgun shooter because I don't do enough other things. So key takeaways, if you switch off now, everybody's had a drink, everybody's had some pizza, you're feeling full and sleepy, don't overload your DOM, every component should be pure, fight me. And every prop should have reference equality. Also, hooks are great, but that's not really in this talk. They just are. Cool. So how do you know if your components suck? Well, if they feel like they suck, right? UX, right? If you're playing with something and it's really sluggish, or if the whole page is going to freeze, we have this component that's basically like an Excel grid, and it's called a list table. And I was deving on it, and I was playing with some large data, and I was inserting a row, and then the whole page froze for 7 seconds. I was like, oh, shit. I tried to load the page again, and that didn't work for 7 seconds. I'm like, OK, I've really messed something up here. And typically, we can find that components stop working because we test it on its own, and it's really fine. And then we put an order of magnitude more on the page, and it stops working, and everything breaks, and it falls over, and we're not really sure why. So we need to start working out how to do that and how to work out why they're failing. And as we said before, Chrome dev tools are really great. I really like flame graphs. Again, fight me. But the great things about these is you can go down and you can find, OK, I'm seeing that my big list table component is updating, and that's actually telling 100 different list table cells all to update, but I only changed one of them. Why is that happening? So you can go in and you can prune it, and you can actually see the results when you are optimizing going through. And I really like the React DevTools extension because it's got this little thing where you can hit highlight updates, and when you interact with all your components, they get this yellow border around them, which is really good when you're hitting a dialog and you hit submit, and then you see all of the background on the page behind the dialog flashes yellow, and you go, that shouldn't happen. And so this is really useful for finding bad optimization patterns in your components. So the big issue, like I said with our list table component, is just having too much data. Right? I just need to show a bunch of stuff on the screen. In this case, it was every single cell in that grid was an input. Right? They all had event handlers. They all had methods sticking on top of them. And it's a problem because if I see a big list of data, I'm going to do a map. I'm just going to go, OK, cool. Children, map it. I'm going to put an item in there, some subcomponent, spread some props in. It's great. But everything that I put on that DOM is going to get rendered. And if it's rendered, it means all of its lifecycle methods and all of its hooks are going to get checked. Even if it doesn't repaint on an update check, it's going to run all that render code. It's going to run all that CPU time, which starts to slow you down. And in aggregate, that really, really sucks. And what does this result in? It's slow load times, it's sluggish responses, and it's really unhappy customers. So TLDR, lots of data, and just throwing it on a page is slow rendering and really bad UX. So what's the solution? Well, we could just split the data up, right? Let's just do the same thing, but just show less of it, right? Let's just paginate. Everybody's played with pagination before. Cool, small chunks. And on paper, yeah, pagination's great, but if I'm a user and I'm on a web store, and I go to Amazon and I search for a thing and they give me 20 results back, I go, oh, I want to see 60. I want to see all of them. I want to infinitely scroll, that's really cool. So why am I being limited by that? Because the developer doesn't want to handle that problem. And so paging is very often part of the solution, and it's typically a solution dealing with the network more than dealing with the front end. It's very rarely the only solution. And when we say, okay, I don't know how to do an infinite scroll, or I don't know how to deal with this DOM payload, and so I'm just going to implement a bad solution like paging only, what we're really saying is that an implementation difficulty is guiding our design decisions, which I really hate. I think if somebody says, oh, this is too difficult, so we're doing a different thing, that's wrong. Again, you can fight me in the pub later. So imagine if in a world where you only had to render the content that the user could actually see. It's great, right? So this is a thing called virtualization, where essentially you put a containing block on the page. That could be the window itself. It could be just some block. In our case, it was the borders of the list table component. And you can combine it with paging as well. So great. So now we can show 60 things per page, but we're only rendering the first 20 because that's all the user can actually see. And so we're only putting those on the DOM. Those are the only ones updating. So we've lost all this problem. This exponential problem we have is now sort of order 1. And so HX internally, we use great library, React Virtualized, which is by Brian Vaughan. He's core team at Facebook. He's great. Library's great. Use it. But I'm not going to go super into detail on that because the fundamental principle is kind of what's interesting. And you can implement these things yourselves if you really wanted to. So shitty diagram, I know. But the core principle is you have some containing element. And if it is inside the containing element, if the user can actually see it, render it fully. Put it on the DOM. Lifecycle methods, interactions. Let people play with it. And going around the outside, you can put a render buffer in, as I like to call it, which is where you might show it. You might even give it all the interactions. So if somebody scrolls really quickly before the render methods can kick in and throw new cells on, that people can interact with it and people can see it. And then outside that, you might leave it blank. You might just put some sort of standard HTML elements that are styled correctly and they look like there's data there, but actually it hasn't got the interactions and the nested and the deeply complex components that you would normally put on that would clog up your DOM. And another nice diagram to kind of see what I talk about here. This is from a really great Medium post. When you get the slides, you should all check out this link. It's really great on a guy just rolling his own. But essentially, if you have a list of statuses, this might be what you would see behind the scenes when you're just throwing everything onto the DOM versus when you're virtualized, right? You're only showing what the user actually needs. So cool. So we're dealt with just throwing data onto the screen. What about the big problem that we've heard people talking about already, which is React over-rendering, just components updating when they really shouldn't. And React is going to do this by default. You do extends react.component, or you're just going to use a functional component everywhere. It's going to render more than it needs to. And you know what, 90% of the time that's fine. React does some really cool stuff. It runs its render function, it compares the new DOM to the old DOM, and it goes, okay, cool, I don't need to update, and it doesn't do the repaint. But again, we're worried about that render time. We're worried about running those lifecycle methods and in aggregate. So we need to stop this. Yeah, it's really an issue, but when it is, and it really is, and when it was a big issue for us, it was a big fix. And I looked at it and I went, oh, shit, I should have been doing best practices from the start. I should have been coding so that this never became a thing, as opposed to being a month sort of backlog, which it was. And that was at the minimum. That was when the app wasn't very big. And so in React, we implicitly are building a component tree, right? Components have children, many children, and they have children. And so if one unnecessarily updates, and maybe it changes a prop, right? That might tell its children to update. And if they unnecessarily update, they tell their children to update. And this problem gets exponential. And so you really need to try and cut it as high as possible. So first thing to do, pure components. I love pure components. They're great. Essentially, pure component or wrapping a functional component in a memo is going to compare your props and compare your state for the class component, or and it's only going to update if those props or state have changed. Right? And it's doing that by shallow, basically reference equality. So you're not going into a list and seeing if the elements in the list have changed, if the list length has changed, or if the object contents have changed. You're only looking at the reference, if the reference has changed, which is fine. This is going to solve a lot of your unnecessary renders, but in practice it actually doesn't. It solves kind of a few of them, but if you've got bad prop passing patterns, if you are doing a lot of the bad patterns I'm going to go into, then this isn't going to help because those bad patterns cut straight through pure component and React memo. And I know what a lot of you are thinking. Oh, I don't need pure component. I use a should component update everywhere. Again, we can fight over this if you want, but I don't think should component update really is a use case aside from when you've got a component that's being passed 15 props and you only care about 3. For the vast majority of cases, you should be pure componenting. And should component update is kind of oh, I'm not really sure, I think I'll hack my way to a solution. And so essentially, I do this, I pass bad props very regularly, I've got it in production code. You all are sitting there, and I hope that some of you are thinking, otherwise I'm clearly a very bad dev, that you're passing bad props. And so we all need to be more disciplined when we're passing our props. So I do actually have some ducks. And if you manage to answer the question, then you get a duck. So can anybody see where the problems are in this code? I'll give you a second. Yes, that is. Would you like a duck? There you are. Awesome. Yeah, you don't get a second duck for that. Yeah, so the first one is this object, and the second one is this function. We don't actually, the title isn't a problem. That's a string comparisons, reference equality already, that's fine. Same with the has family bool, that's fine. That's a quick check. But the object, every single time that this function runs, that's going to generate a new object. And it's going to pass a new object to the child, which means that the reference equality fails. New function passed to the child, reference equality fails. So even if that child is a pure component, doesn't care. That's breaking it. And if this, in this case, if on-child close was changing all the time, this would update, and then its child would update. Imagine you've got 10 children in here, exponential problem again. Oh. Huh? No, sorry, they're just covered by the border. Yeah, so maybe, right, we can solve this with classes, right? Let's convert this to a class component. And if anybody ever actually says that to you, shoot them. Essentially, yeah, we could make this a pure component, and we could solve the style by, well, actually, our style here, it's got the width, which is coming from the prop, so we can't do it in the render function anymore, and we can't do it in a function and call that in the render. So actually, what we've got to do is we've got to put it in the state, and then we've got to use a lifecycle method and check if it's changed, and then set the state, and then use that, and then we get some rudimentary memorization in our class components. We could do this with a memorization library if we wanted to as well, but we're assuming you haven't got that. But for the function, that's really easy, right? We just use a class method, okay? And if we use this class method, this is going to get instantiated when the class is created, and when the class is instantiated, and then this reference is the same for the entire lifecycle of this component. Cool, right? That's really simple. Well, it's not, because it's not using hooks, and everything's better with hooks. So if we were doing it as a functional component, we could use hooks. Our close child is now a use callback hook, which is only updating whenever on-child close changes, which is cool. This is relying on the fact that on-child close has got reference equality, because the hook comparison is going by reference equality, but we're assuming that you're doing good patterns throughout your app. And then the child style is a use memo, which is a very similar thing. I mean, a use callback is a use memo that returns a function anyway. And so that's only updating if the width changes. And we're assuming here the width is a number, so that doesn't actually matter. It's only going to update when that changes, so the child component is only actually going to update when it needs to. So cool, we fixed this component. Now, a little bit of Redux for the people here who use Redux, which I assume is a number of you. Yeah. Okay, cool, great. There are a couple bugs here as well. Can anybody see a bug, which will cause some unnecessary re-renders? You get a duck. Anyone? I'll give it a little bit of time. Want a hint? Yeah, did I hear something? You get a duck.
You're missing the key. Do you want this? Because I really want to throw it. I missed out last time. So.
Yeah. Anyone?
You're missing the key there.
The key? Don't think I am. Anybody else?
So it's the right lambda there.
Yeah, so awesome. Okay, do you want to duck him, Richard? That's his job. His job is here to duck people. Thanks, Rich. So yeah, there are two problems here, right? In your map state to props, right? Map state to props is binding new props to the thing, okay? So it's like you're passing it from a parent component. It's just it's not coming from the parent, okay? So here, every time that this map state to props runs, it generates a new list. Okay, so we're breaking reference equality again. And that then gets passed down, and we've broken it. Map dispatch to props, doing the exact same thing. Every time that this runs, it's going to pass a new function down, and we've broken reference equality again. Now, you're thinking, okay, cool, well, my HOCs don't update all the time using Redux. Every time that your state changes, your HOCs rerun. your state changes anywhere in the app. It doesn't matter if it's not using user or if it's the dispatch hasn't changed. It's going to rerun these. So you're going to get a new reference equality passed. So you've broken reference equality way more often than this component needs to. So we can fix this. And it's really easy to do. Again, this memorize function doesn't exist. I'm assuming that you're using some library for memorization outside of a function. I've written this to look like a hook so people can implicitly understand it. But essentially, if the friend name's prop changes, or if the part of the state we're actually looking at, so this is really great. It's instead of just going with state, we're going with state.user. So if other parts change, we don't care. If either of those change, we pass a new friends object. Great. This is the fun one. Did anybody know about this pattern? Cool. One guy, give him a duck. So essentially, what's happening here is we are taking the dispatcher and we are wrapping our action creator in the dispatcher and passing the props through, and we're just spreading them through. And this is such a common pattern in Redux. It's all over their docs, so everybody does it because you read the docs and you go, oh, cool, great, I'll do that. It's so common that that does the same thing, except it does reference equality. And so it just creates it once for the lifetime of this HOC, and it never changes, which is super great. So we don't even need to worry about updates. I will say, if you use the second argument of this function, you're going to need to do some memorization stuff, if you use unprops. But I haven't seen anybody do that yet. So come to me with an example and we can chat about it. And you might get a duck. Cool. Another thing I want to touch on, if you see on this one, right? So we're using friend names and we're building the friends prop from it, right? I imagine this is sort of a social media app, like you're trying to show your list of friends, okay? And actually, the subcomponent that this is being bound to, that the HOC is wrapping, probably doesn't need friend names anymore, because I assume that the friends thing that's getting mapped to has got the name in it somewhere. So you probably don't need friend names. So we don't want to pass it to the component. If friend names is updating all the time, we don't want to pass that through. We only want to care now if friends updates, because that's super lovely and it only updates when it needs to. So I do this thing called prop filtering, which is essentially where I will just have a buffer kind of functional component that takes all of the props in that this component getting passed, and I sit and I go, okay, actually, what do I need? And make sure that I only pass those. Because if you're using some context API somewhere and you're passing some props down, you overuse the spread operator like I do, then you find yourself throwing in a bunch of extra props that you don't actually need and that component doesn't need, but that might break its reference equality. You don't want stuff updating for reasons that for when it shouldn't. Again, you do this a lot, and if you do it with 30 props, then it looks super fucking ugly and takes 60 lines. But otherwise, it's great. So thanks. Try to keep this short and snappy. I was going to put up a bunch of stuff for supplemental reading, but Google's your friend. There are lots of really great Medium posts on optimization and performance, and also you've just seen another talk, really great talk on it. And you can ask me in the pub as well. But there is a really good textbook to helping you write React that I will advise that you look over. So thank you very much. I've been Elliot, and that was my talk.